Okay, everyone, let's do some more IM3 extra credit for some of you, okay? But this is reviewing some more stuff you should definitely know on IM3. And you just got the handout if you're in my class today, so let's get this going. So here on number 1, you'll notice we're working with logs and natural logs. But before we do any of these, let's remind ourselves of some basic exponent rules. For example, does everyone agree if I take x squared times x7, that's x to the 9, because I would actually do 2 plus 7 to get 9, right? In other words, when we multiply with exponents, we actually end up adding the exponents, correct? That was a rule we learned. Similarly, if I take x8 and divide by x3, would we not get x5? Why? Because I would simply right here do 8 minus 3, right, to get 5. In other words, with divide or division, we subtract the exponents, right? And finally, there's a third rule we may not have talked about recently, but does everyone agree that if I have x to the 4 here, to the third power, so I refer to this as power on power right here, we end up multiplying, right? That's a little extra multiply there. And that's how we get 12, right? So in other words, when we have an exponent or a power, as I like to say, we end up multiplying those powers, right? And so the reason why I bring this up is with logarithms, since they're the inverse of exponents, well, we simply do these rules backwards. So when we see an add, we know we can make it into a multiply. When we see a subtract, you see, we know we can make it into a fraction or divide problem. When we see a multiply, we can actually make it into a power. Okay? And you're going to learn to use this rule backwards and forwards, as you're going to see for the rest of this video. So let's get going back to number 1. So what we have here simply is a log, a natural log, right? And notice the power up here. Well, remember with powers, we just learned with powers on power like this, we can make it into a multiply. So basically, we're going to take this 6 power, bring it in front, and make it into a multiply. And these are equivalent, guys, in the world of logs and log functions. So the 6 right here came from bringing that 6 power down, because with power on power, we now know it's a multiplier as well. Now, what about, look at the parentheses now. We have a there divided by b to the 3, or b cubed. Well, didn't we learn with the rules that dividing ended up being a subtraction, right? So we can now rewrite this as 6 natural log and of a, I'm going to keep the 6 and natural log together, minus 6 natural log of b cubed. Okay? So again, we took the a, since it was divided by b cubed, and we know, sorry about the school bell there, guys, but we know that with divide, it actually is a subtraction problem, right? That's why we did the subtraction. Now, if we look at our problem, this is basically done. You can't simplify 6 natural log of a any further. We have a minus because of the divide right there again. Over here, though, see this 3 power? Could I not bring it in front and multiply by 3? So 3 times 6 is 18, natural log of b, and now that's completely done. We call this, guys, expanding the logarithm function or expression, okay? Expanding means we follow the rules and we expand it out. It spreads out into simpler, smaller pieces. Okay? Now let's follow these same rules with the next several problems. Look at number 2. This one does not have an extra power out here per se, like this, right? So this one's much more straightforward. We have a divide here, however. Well, what do we know happens with divide? We can make it into a subtraction, right? Sorry about that announcement interruption. I'm not having a good luck here so far. But anyways, the division right there means we're going to change it into a subtraction. Now, if you look at our answer, guys, we're not done yet because don't they each have a power on them? And we can bring those powers in front, you see? So our final perfect answer is going to be a 2 natural log of u minus, the 4 again goes in front, 4 natural log of v. Now we totally expanded that expression. And we're done. Okay, pause the video if you need to. We're going to do a couple more now. Look at number 3. Notice this one, again, doesn't have any power out here, right? So it's a pretty straightforward problem. We basically have x3 or x cubed times y to the 6, right? Well, what does multiply do, actually? It becomes adding, right? So this can be written as natural log of x cubed plus the natural log of y to the 6. Look at our answer now. Don't we have some powers that we can bring down in front? So our final perfect answer is 3. The 3 came from here. Natural log of x plus the 6 natural log of y. Done. All right, let's do one more. Here we go. I think this is the last one. Here we go, number 4. Now, guys, this one, the only tricky part is, do you still remember what a radical actually is as a power? A square root, for example, is a 1/2 power. So the trick to this one is we're going to first rewrite it. Okay. We're going to rewrite that. And you'd probably be tempted to multiply that together. But guys, trust me, just leave it separate. Okay? Don't multiply it together. But that whole 12 times 5 times 11 is a square root of. So does everyone remember a square root is a 1/2 power? Hopefully you do. Just like a cube root would be a 1/3 power, right? But anyways, now that I made it into a power, do you agree I can now take this 1/2 power and bring it in front? So now I have 1/2, the natural log of 12 times 5 times 11. Again, don't multiply these numbers together or anything, because with multiply, you see, we know that can be changed to adding, right? So I have a 1/2. Now this time, using distributive property, I'm going to put a bracket or a parentheses here. All right, that 1/2 is going to stay for the whole problem. I have the natural log, you see, of 12 plus the natural log of 5. Again, that times means plus, actually, right? And then we have another times here, so plus natural log 11. So there's my answer. The only thing I could do, of course, is keep the 1/2 and natural log together here. As you can see, I could do it here as well. If I distribute that 1/2, another good version would just be 1/2 natural log of 12 plus 1/2 natural log of 5 plus 1/2 natural log of 11. Pause the video if you need to. But anyways, guys, I hope you watch this video more than once. Study it. Get a little familiar with these log rules. Remember, we were doing natural logs, but they would apply to any logs as long as they were all the same base log, okay? But I'll see you in class.